Okay, so to save a little bit of time, I went ahead and wrote down some ordered pairs. I'll show you. I wrote down this one, this one, this one, this one, and this one. Those are the ordered pairs that I put in this table over here. And you don't actually have to understand that it's two transformations, that it's reflection and a shift. We can just simply plug and chug. You will do a section, I think it's in activity 10, where you do have a combination, but right now you don't. But what you're going to see once we get this done, that it actually is a reflection. So let's just do the math. So all we have to do to figure out, notice I just copied down the Y values again. Why? Because this says that the Y values don't change. So the only thing I'm calculating are the new X values. And this is how I calculate it. I say 8 minus 0. 8 minus 0 is 8. 0, plug that in right there. So 8 minus 0, that's also 8. Then I'm going to plug in 2. 8 minus 2 is 6. 8 minus 2 again. So I have a point at 6, 4. And then 8 minus 4. 8 minus 4 is 4. Okay, those are the new points. I have a point right here at 4, 5. I have a point at 6, 4. And I have a point at 6, 6. And those are the ends of the arrow. I didn't find those inside points, so I'm just going to go here because I'm going to just copy this. It looks like it goes about halfway. So I'm going about halfway. And then the ends of the arrow right here are located at over 8, up 4.5, and at 8, 5.5. So that makes the end of the arrow. Okay, and now it says, so we've done part 6. It says draw the reflection and identify the line of reflection. So here's your line of reflection right here. And your line of reflection is the line. Which axis is it crossing? The x-axis. Where is it crossing the x-axis? At 4. That's the equation of the line. If you were going to write it in the form of reflection notation, you put that funky looking R, and then you do x equals 4. My equal sign turned out ugly, but okay, so that's that part. Which tuba player travels the longest distance? Well, it would be the longest part of this one, and then he's got to do it again. So this poor dude right here has got to travel the longest distance. So it's the guy at 0, 5. So the guy at 0, 5, at 0, 5, because he has to go all the way to 8, 5. Okay. And that is a distance of 8. So I don't know what the unit measurement is. I don't know if this is 8 feet, 8 yards. It might have told us somewhere in the problem and I missed reading it. But the distance, identify this distance. It's a distance of 8 something, 8 units. Which tuba player does not travel any distance in the reflection? Who gets to stand still? Well, this guy right here, he just marches in place. I've seen marching bands. They don't actually get to stand still. They march in place, right? So the person at the tip of the arrow gets to stand still and march in place. Explain why this reflection does not change the distance between any given tuba player and the 0.45. So they're asking me, is the distance from these two people any different on this side of the line of reflection than it is on this side of the line of reflection? And the answer is no. Everybody is the same distance away from the person at the point of the arrow because we kept the size is the same. We did not change the size. So in terms of the size of the arrow, this was rigid motion. Remember the vocabulary word that we did the other day? Rigid motion. The size did not change. The orientation did, and the location did, but not the size. So this was an example of rigid motion. And that's going to be the end of the video. We're going to get to do some cool technology here for this. So I'm going to go ahead and stop this video.